In this video, in the divisibility series, now we are going to talk about divisibility by composite numbers, right? So divisibility by composite numbers. Hopefully by now you've seen our other videos on divisibility by different prime numbers because that's what is going to form the basics of how we approach divisibility by composite numbers. So let's take an example. Let's see if we have to check divisibility of a number by 15. In other words, we have to check whether 15 is a factor or not. Now the number who needs to be checked for being the factor, what we'll do is we'll factorize 15 itself. 15 is 3 times 5. So whichever number has to have 15 as a factor must have 3 and 5 independently as factors. So what we will do is we'll check that number independently for 3 and then independently for 5. If it passes both these tests, then we are going to say that yes, that number is divisible by 15. Let's take another example. So divisibility by 6. 6 is 2 times 3. So it has to pass the divisibility of 2 test. It has to pass the divisibility by 3 test. But problems start to arise when there are numbers like 12. So if we have to check whether a number is divisible by 12 or not, 12 is 2 squared times 3, right? Or let me actually just list down all the possible factor pairs of 12 and see which factor pair suits it. Now, picking the factor pairs in simple composite numbers is fairly easy. In here, we just needed to pick a 3 and a 5. For 6, we just needed to pick a 2 and a 3. But for 12, the number of factor pairs is quite large. So 1 and 12, this is the first factor pair. Then 2 and 6, that's the second factor pair. 3 and 4, this is the third factor pair. So which one is the best to pick? Now clearly this doesn't help us in checking divisibility because 12 is already what we are looking for and 1, anything is divisible by 1. What we now have to do is take our pick between 2, 6 and between 3, 4. Now for all those who would check for divisibility by 2 and 6, they're going to face a problem, and I'll show you how. Let's take 18 as an example. Let's take 18 as the number we are going to test whether it is divisible by 12 or not. Now 12 being equal to 2 and 6, let's check whether 18 is divisible by both 2 and 6. So is it divisible by 2? Yes, it is. Is it divisible by 6? Yes, it is. But is it divisible by 12? The answer is no. So there is something wrong with this factor pair, right? 2 and 6. Something is not right here. But when we check 18 for 3 and 4, so 3 and 18, right? So 3, 6 the 18, this is fine. But 4, 4 the 16 and 5 the 20, it fails here, and clearly this looks like the 3 and the 4, this looks like the right test to follow for 18. But how do we select which factor pair to choose? Before we go there, let's pick another example. Let's pick the example of divisibility by 75, let's say. So we have to check whether number is divisible by 75 or not. Now I'll just prime factorize 75. The prime factors of 75 are 3 times 5 squared, right? 25, 3 the 75. Now all the factor pairs of 75 are 1 and 75. That's the first factor pair. Then we have 3 and 25. That's the next factor pair. Then 5 and 15. That's the next factor pair, right? So I guess that's it. So these are the 3 factor pairs for 75. Which ones should I pick? Again, 1 and 75 doesn't help because we're anyway testing for 75. Now let's choose between 325 and 15 and 5. So let's pick a number 90 and check whether 325 is a better test or 515 is a better test. So let me check for 5 and 15 first. So is 90 divisible by 5? Yes, it is. Is 90 divisible by 15? Yes, it is. But is 90 divisible by 75? Absolutely not. Let's pick the other factor pair. The other factor pair is 3 and 25. Is 90 divisible by 3? Yes, it is. But by 25? No. So clearly, this factor pair is again showing a better, it is definitely better, right? It gives us the perfect answer to whether a number 90 is divisible by 75 or not. Now, do you notice what is common between a factor pair like 3, 4 here and 325 here? What is common between 3, 4 and 325 here is that 3, 4 is a pair of coprimes, right? 325 in the second example is again a pair of coprimes. Now, why coprimes? They give us better results for divisibility by composite numbers. The answer is pretty simple. If these numbers, they have nothing in common, then by testing for 3, I have not infringed on any rules for 4. And by testing for 4 separately, there is no element of 3 in here. But see what happens in 2 and 6. If a number is testing okay for 6, then it is by default testing okay for 2. So I am adding no value whatsoever in testing a number for 2 separately. Alright. Likewise, look here. For 90, if a number is divisible by 15 and there is a 5 and 5 common in both of these pairs, right? 5 and 15, there's a 5 common. The 5 here is already being tested. So there is no value addition for 15. This test will always throw a positive result for all the multiples of 15, but that's not what I'm looking for. I'm looking for multiples of 75 and not 15, right? So therefore, it is always, to get the right divisibility test, for a composite number, it is best to split that composite number into coprimes, as many coprimes as possible, right? So what I'll do here is simply all the powers of 2 grouped together, all the powers of 3 grouped separately. These become my coprimes, 4 and 3. This works perfect. Then look here, all the powers of 3 and all the powers of 5, this separate, this tested separate. There is absolutely no problem, right? So anything that passes for 3 has no business with 25. Anything that passes for 25 has no business with 3. Therefore, picking up coprimes is the most important thing when you have to check for divisibility by composite numbers. Obviously, we can't test for all composite numbers directly, so we need to split them up. How you split them is you find coprime factors of this number, right? So while it works here we have to be careful whenever higher powers of basic prime numbers are involved.